A super quick anecdote before I jump into mine, just to kind of show you the value that some of these things are adding. I've gone from very seldom using any kind of generative AI stuff probably beginning half of last year to I probably spend a good 30 to 40% of my time now using and developing specific prompts or tasks, trying to automate as many tasks that I can. So, for example, with QuickSuite, we've actually you can go on and you can have a look at the service yourself to see what it is, to see how it works. But essentially, what I've managed to do is I've managed to actually take it and create automated flows so that it can do things like before I'm going to meet with the customer. It will, whereas I used to go in, go through, pull out information, from different sources. I've managed to optimize their flow. So what would previously have taken me 2 or 3 hours, I can now get in less than 5 minutes. So I can pull that information in. I've done some things around optimizing some of my workflows around using my email and my calendaring and so on. They sound really simple and they're not the really shiny things that everybody thinks of. But definitely, I think in terms of optimizations, they're helping. And the other thing is, I've managed to, I'm not a coder. I'm not a developer. I never have been. My life has always been within networks and security, infrastructure side of things. But in the last 2 days, I've managed to build a complete application on something that I'm working on. And I never would have been able to do that in the past. So they're definitely taking hold. They're definitely using, improving what we can do. And if you're not using them, I'd highly encourage you to look at them. If you've got the opportunity, definitely start looking at them. But what we're going to talk about now is something that I talk about quite a bit, which is what is agentic AI and what is, how does it relate? How does security relate to this topic? So if we start thinking about it, how AI has evolved, we started off a long time ago. I think it was back in the 1950s where artificial intelligence was originally mentioned. We've come a long way since then. But if you look back at what's happening and where this was going, what would happen is we started off with these machine learning models where you would basically take some data and you would run a model against it and it would produce something. So it would predict or classify based on the models. So our house prices, based on this data, our house prices in this area likely to go up or down over the next coming years based on these environments. Or what's the weather going to be like and so on, right? So really simple machine learning models. Security was just there was a foundational layer of security. The focus there was on things like just data encryption, identity and access management, very, very specific things, because all we were doing is we were putting something in saying, give me a prediction or give me a classification. Right. We then moved on to generative AI assistants. So it was late, if I remember my dates correctly, it was about November 2022, when Anthropic sorry, not Anthropic, OpenAI launched ChatGPT. But actually, nobody really took much notice of it. Nobody really heard about it. There was a bit of a low-key announcement until March 2023, which was when Microsoft did their big launch with their OpenAI and ChatGPT and Copilot, and that's when it really started taking off. But then what we came across here is actually these generative AI assistants. They were following a set of tools. You could do automated tasks, but there were new attack vectors that were coming in, things that we had not really had to deal with before as security professionals. So things like content filtering from models, input-output sanitization of natural language, things like prompt injection attacks, which are still a challenge today, but things are improving. So we went through that, and then we started into beginning of 2025. We started going through this migration into and this evolution into AI agents, which is around taking all of the things that we've done before. But now what we're doing is we're giving the application, combined with those large language models, the ability to actually do something. So take action on something. So now what you've got is all of those other security controls around data encryption, identity access management, network segregation, you're dealing with prompt injection, protections, content filtering, everything relating to all of that. And now what you've got to deal with, now you're starting to look at, actually, we're giving these agents the ability, the things like zero trust and how we can control what's happening with the agents. And now we start looking into how agentic AI is changing, right? So we took a long time to go from machine learning to generative AI. It's been relatively quick to go from generative AI to agentic. And now we're accelerating even more, where we're going into multi-agent, fully autonomous systems, right? So that first wave, generative AI, was really simple content generation. Give it a prompt, it gives me something back. Give me an image, or give me a prompt and give me an image back. Help me summarize something. Generative AI is really powerful, but it waits for you to tell it what to do in most cases. Then early agents were starting to do some form of actions or reasoning. So they would look at something, break something down into smaller steps, and actually do a couple of steps, right? So they were still used for really simple, well-defined tasks, conversational agents that could retrieve information, answer customer queries, gather information. But then, like I said, over the last year, what we've really started seeing is these multi-agent, fully autonomous, complex agentic environments where you're getting them to do multi-step workflows and change to the environment based on what information it's receiving back. Right, which makes it really difficult, right? It's a new way of thinking. We need to understand these. Now, when you thinking about all of this, right, there are three key things that I think really bring this home. The first is AI is becoming, forget about will, it is becoming embedded everywhere. So we've seen all of the changes around productivity gains being mentioned, the speed at which we can do things. It's going to be embedded throughout everywhere. So even if you are not directly using it today, what about your supply chains? What about further down the line, right? So whether it's infrastructure, your applications, supply chains, AI is becoming embedded everywhere. And you really need to start thinking about how these actually integrate with everything else. So you really need to start considering how security can be embedded everywhere where AI is integrated. Because AI is starting to become integrated with everything, it's starting to cross traditional boundaries. So they connect databases, APIs, external services. A single AI application might touch your CRM system, a data warehouse, a e-commerce system, third-party APIs. So we really need to start thinking about how do we expand or how do we make sure that we really start implementing things like defense in depth to start protecting everything from that infrastructure layer right the way through to the applications. And then the final thing here is that in an ideal world, everybody would have their security foundations. Everybody would have really good enterprise-wide security. Everybody would have everything just running really well. The reality is budgets, time constraints, different direction from within organizations, leadership's time. Sometimes we don't always get to that point. But what we are hoping is that as people are going through this process of integrating AI, what we're really trying to hope here is maybe this can be used to help drive those enterprise-wide security improvements. So as part of we need to start building our AI strategy, and we need to start building these AI applications. We might actually find that it actually helps. It adds as that catalyst for broader security improvements, right? So actually implementing things like the zero trust and the least privilege and the continuous monitoring, or expanding coverage where there may have been gaps previously. Maybe maybe this is where leadership are going to start being able to say, actually, we need to get these things done, right? So we really need to start think of, rather than securing longer term strategically, rather than securing AI, we need to start thinking about actually securing with AI in mind. So design security architectures that assumes AI is going to be integrated everywhere, and build those frameworks that can easily adapt based on what's actually being used and what's being deployed and what you identify in your environments. So with that, I mentioned very early on who's been doing anything with generative AI and AI agents, and there was a bit of a mix, right? There was some people who said yes. There's one person who said they're actually doing quite a bit with it, but there were quite a few people who were unsure or saying, actually, I've not done anything, or indicating that it's very limited. So let's go back to the very basics here, because this is fundamentally important when we're trying to figure out what do we do around securing agents, but also how we can use these agents within our security environments, right? So within AWS, we define AI agents as autonomous systems or autonomous software systems that you So as I mentioned earlier on, I've been doing some experimenting. I've built a complete application to check for compliance within certain systems. Quite interesting, but that is the beauty of agents, is they've got that ability to do that. Now, when we consider, we've given that definition of what an agent is, but if we now break these parts down, this is now where we can start thinking about securing. This is now when we can start thinking about what we have to do. So we start off with the actual agents, and the agent is essentially code, right? So the agent is code, and what it's going to do is it's going to work with memory. So the memory provides that ability to retain conversational context across different sessions, and also pull back and recall past interactions and behaviors. So depending on how your application is built and what you're doing, you can either just have it so that it's going to be on a session basis, or you can pull back long-term memory from multiple hours, multiple days, weeks, etc. We then have tools. These are fundamental for agents. Just like us as people, we can't do our jobs without the right tools, right? So yes, there's a bunch of example tools on there: calendars, calculators, code interpreters, and so on. But this can be as big as your imagination makes it, depending on what the agent is being used for, right? They could be internal, external tools built as MCP servers. It really doesn't matter. This is how the agent is going to do what it needs to do. The final piece of the puzzle here is planning. So when you ask your agent to perform a task, it does what it needs to do. It plans it. So it reflects, it self-critiques. Is this the right thing? Should I be doing this? What are my options? Right. It uses things like chain of thoughts, and it breaks things down to give those sub goals. My big goal is this, but what do I need to do in order to get there? What do I need to achieve? And it uses this planning. It takes information and the context from the memory, and then it uses those tools to then actually take action on your behalf. So this is whether it's a case of you're allowing it to automatically go ahead on autopilot to do these things, or whether you want to do human in the loop for certain actions. This is how an agent works. So now that we've got that fundamental understanding of an agent and how it works and the different components, we really need to start thinking of, if we're going to be securing our agentic applications, but also how we can use these applications for security, we need to start thinking about how to layer in defense, how to layer in security. And in order to do that, we need to take it a little bit further. So we really need to think about, so what changes with AI? What do I need to do differently? How do I do it, and why? Right. So there's four things that we think fundamentally, or these four characteristics that fundamentally change how we think about security when it relates to AI. So these characteristics. Now, the first is functionally they are non-deterministic, and what I mean by non-deterministic is that security it comes when you're using a traditional security control like an access list or it's a very clear Mark has access to something or Mark doesn't have access to something. It's very deterministic based on my identity. It's a yes or no. There's no gray areas. There's no, well, maybe. It's a very yes or no. Security, when you're using a large language model, whether it's an agent or generative AI, but when it comes to AI, essentially it's non-deterministic because you can't predict exactly what the AI is going to output for any given input. We've all done this. Hopefully you've seen this. If you've experimented with this, you can ask the same question 2, 3, or 4 times, and you potentially get different words back each time. Right. So that same prompt might return sensitive information one time, it might not another time. It's purely based on the predictive nature of the model and how it determines the response. So it starts to get really difficult because you can't create a regular expression that matches every single output in natural language. Input becomes code. So the user prompts now become the instructions that the AI executes. Now, previously, if you recall, what you would do is you would have your controls plane on the background, and you'd have your control and your data planes. And what I mean by that is you would have all of your, if you had like a web interface connecting to a database in the background, when you were giving information, what would happen is there was a separation between here's the information I put in, and this is what the infrastructure does with it in the background. What we're now doing is with AI, you're blending your information and your prompts together. And what I mean by that is I will, through a chat or through an agent, through a natural language query, I will put some text in. That text gets combined with the prompt that says, this is the information around all of this, that all gets sent to the large language model. So it comes all together. And what happens then is it makes it really difficult for the AI to distinguish which bits are from the end user, which bits are from the application. It puts it all together, and effectively that whole thing is code that the large language model has to interpret and execute. And what we start seeing things like that is it takes everything. Hopefully everybody's heard about prompt injection, which is where you inject malicious code in natural language to try and get the large language model to do something. It blends all of this together and makes it really challenging, right? So how do you deal with that? The third is this autonomous decision making. So we start looking at the fact that actions can happen without human oversight now. So the AI, the agent, can actually decide to access databases, call APIs, or even modify data based on its own reasoning. And a compromised agent could perform unauthorized actions against your systems. It could delete things. It could alter things without you knowing and without you asking it to do so. And then the final piece here is around dynamic learning and adaptation. So security posture changes over time. We all know that. And the AI behavior evolves based on those interactions and feedback. So because what it can do is it can take data in, it can learn, obviously depending on the applications, but it can learn from that. What happens in the situation where if you have got a manufacturing environment with lots of IoT devices, and in order to compromise the system, what you're doing is you're constantly just pushing in slightly anomalous telemetry readings. Nothing enough that's going to flag on the system, but long enough and significant enough that over time, the agents and the AI systems see those behaviors as normal, and all of a sudden that has been exploited. Right. So it's around continuous monitoring. It's around making sure that we understand what's changing within the environment. So although traditional security controls still apply, there are some things that we just need to add that are AI specific. And where it really changes is there are two main aspects, security and responsible AI. They are very different disciplines, but they often get confused. So security is all around focusing on protecting the systems, data, and the infrastructure for malicious attacks. And responsible AI is all about making sure that the AI behaves ethically, it prevents bias, and it avoids generation of harmful, inaccurate, or misleading content. It's about fairness, and this is around ethics, governance, and societal impact. And quite often these two things get blended, right? What we're really, really good at from a tech industry is focusing on security. So when we start talking about these things, the way we've started, well, the way we generally approach things within AWS from a security perspective, when we're talking to customers, is let's focus on security outside the model. These are the deterministic things that we can control. So we use predictable security mechanisms, tools like firewalls, access controls, encryptions. So unlike AI models, where they're producing natural language, the prompts change all the time. The security controls that we can put in terms of who can access, who can access the agents, what the agent can do, and so on. Those are always going to be deterministic, and they're going to produce consistent, reliable results. So an example is an IAM policy that always enforces the same permissions, regardless of the request content. Right? So controlling what can be done, when, where, and by who. We talk about security before the data reaches the model. So implement controls at the perimeter. We'll hear some of these through the rest of the session. Just like you would never ever stick a enterprise web server on the internet without putting controls in front of it, like a web application firewall. Why would you ever do that for this? Why would you allow anonymous access? So it's about things like filtering and validating inputs before they get to the model, making sure that you're authenticating users and authorizing the access and sanitizing the prompts before it reaches the model, so that the model can the best data possible and the most secure data, and only from the right places and the right people. And then we always talk about defense in depth around having multiple layers. Now, the challenge with that is it does depend on scoping. 2.5 years ago, this was late 2023. So we created something called the security scoping matrix. We've got a series of 5 blogs on this. There's a lot of information here. It is vendor agnostic. The idea here was that we wanted something that would give everybody a framework that they could follow and look at for generative AI security. So what we did is we categorized generative AI applications, and then for each scope, we documented what the primary concerns were around things like security, privacy, legal, resilience, and then we put these all together. So if you think of scopes 1 and 2 here, very, very quickly, scope 1 is a consumer application, public generative AI services. This is your typical Claude Code, ChatGPT, Amazon Party Rock, and so on. They're free to use services. You can go and use them. You have no control over the terms and conditions. You really have no control over what happens with the data or anything that goes in there. Scope 2 are enterprise applications. This is where you've got applications or SaaS services with generative AI capabilities built in. You've got a little bit of control. You do some risk assessments, and you've got terms and conditions with the vendors, but ultimately they still manage everything. So those are what we refer to as our buy services. Scope 3, 4, and 5 are your build services. So scope 3 is using pre-trained models. So you build your application using a version model, those foundation models, your Amazon Nova models, your Anthropic Claude models, and so on, right? You take it as it is, you use it as is, you don't make any changes to that. You're responsible for building the application and securing it. Scope 4 is around fine-tune models, and the concerns and the challenges that come with fine-tuning a model, looking after the data, curating the data, and so on. And then scope 5 is around self-trained models and building an application that relies entirely on your own data sets, your own models, etc. Comprehensive security across the entire machine learning pipeline. What we did is in late November, we launched the agentic AI security scoping matrix. So we're still taking feedback on this at the moment, but we published this, and we broke this down into, there are essentially 4 types of agents. No agency, where the application doesn't do anything automatic. There's no change. It is human initiated. You use traditional application security for these. We've got scope 2, which is where we've got human initiated, but only specific actions are allowed to be done. We've got scope 3, which again is human initiated, but there's automated actions. And then scope 4, which is full agency or fully automated, right? So this is automated initiation and automated agent actions. And very quick examples of these, right? So scope 1, I go to a meeting, I take some meeting notes, I come back, in my meeting notes, it says, I need to schedule a meeting with Chris, with Shweta, and with Miriam and Piotr. The agent goes away, has a look at my calendar, and it says, Mark, these are the dates where everybody can do everything. There's a common time frame. I go into my calendar, I make the change, I send out the meeting invite. Very simple. Scope 2, exactly the same scenario. I come back, and what it does is it then says, here, Mark, I've created the meeting invite for you, but you still have to send it. So I review the contents of that. Once I've reviewed it, I say, yes, go ahead and send the meeting invite out. The third one is, again, I've got my meeting in notes. I drop them into a folder. I say to the agent, I need to go and schedule this meeting. The agent will then go and look at my calendar. It will look at Shweta's, Miriam's, Piotrek, and Chris's calendars. It will find a common time, and it will automatically generate the meeting invite and send it on my behalf. Right. And then scope 4 is something where, again, I come out of the meeting, I take my notes that I've written, I save them into my folder. The agent automatically notices that there's been a set of meeting notes put in there. It looks at it, scans through, automatically detects that it needs to create this meeting and schedule this meeting. It will go find the time, and it'll schedule a meeting on my behalf. I've not had to do anything. I've not had to tell it. It's built into the agent. So you can see all of the different scopes there. Now, from left to right, obviously, traditional security on the very left-hand side, because we're not doing any changes, right the way through to full real-time monitoring, supervised continuous monitoring of everything the agent is doing. And you really want maximum security controls in there if it's got the ability to access your emails, send meeting invites, check data, and so on. So what you really need to do, and the key insight here is you want to match the security investments and the amount of time and what you're putting in to your AI scope that you are using. Most organizations start from left and move to right. In fact, most organizations that I'm working with at the moment are, from an agentic perspective, are currently sitting at around scope 2. Between scope 1 and 2, there are some that are dabbling in scope 3. I've not come across anybody yet that is in scope 4. I've heard people talking about it, but we're not there yet. So we always talk about defense in depth. I've got 2 more slides and then I'm going to hand over to Shweta, but we always talk about defense in depth, right? So this is really, really important when it comes to this. Today, we're going to be focusing on predominantly network and edge and infrastructure protections. But before I go on to Shweta, before she talks about the overview of AWS AI security services and how some of these services can help, I just want to reiterate, we go back to, remember that original diagram that I had with the agent and the tools and how it was working. I've got a slightly simplified diagram here. So we've got the client, we've got our application, we've got our large language model, and we've got our tools. What I really want you to take away from this is when you're looking at how do you protect your applications, there is a lot to do. There's a lot to think about. And this session, I usually run a session that's about 90 minutes long, and we go really deep into a lot of these topics. But I just want to pull these ones out for you really quickly before we hand over, before I finish up and hand over. You really want to start looking at how do you protect what's coming in, right? So your endpoints, DOS protection, so things, basic service, edge services like WAF and Shield Advanced. You really want to look at rate limiting as well, again through WAF, right? So protect those applications. We've got network segmentation, so things like network firewall and VPCs. We've got zero trust networking, so verify all those connections. Remember what we were saying earlier about making sure that only the agents can access the right things when they need them based on those authenticated and authorized actions. And then you want to make sure that you block any access to any malicious domains and services through additional edge services. So things like Route 53, DNS firewall, and so on. I just wanted to tie some of these together to show you when we're talking about how do we protect the things, how do we protect our services? We've got a lot of services, native services that can do this. And the thing that I really want to emphasize here is as we go through, and when you hear Shweta and when you hear Miriam talking, we're talking about our foundational services that have been around for a long time. And that's because we follow those same principles. Remember what I spoke about earlier? Let's use the deterministic security controls before we get to the models. And you're going to hear a lot more about that over the next hour and a half. So with that, I'm going to hand over to Shweta. Thank you very much. I'll be coming back a little bit later for the demo, but Shweta, I'm going to hand that over to you now. Oh, you're on mute still.
Okay, so you hear me now?
Yes, got you.
Yeah, okay. And you see my screen, right? Yeah, okay.
Yep.
So, yeah, I'm Sweta.